In this video, we'll generate the trendline dataset and trendline polynomial of the Q function using NORMSDIST and the GAUSS function. We begin with the Taylor-Maclaurin Series sum expansion of the Q function, which is 0.5 times the summation of a times x over square root of 2 raised to the power 2n plus 1 all over square root of pi, where the coefficient a is equal to negative 1 to the power n plus 1 all over n factorial times 2n plus 1. And the value of n is 0 to infinity, so we can go as far as 16. We continue with the coefficient, which is our formula, minus 1 raised to the power n plus 1, the quantity n plus 1, divided by, there are two parts, factorial of n and the quantity 2n plus 1. So factorial n times the quantity 2 times n plus 1. Now we can complete the Taylor-Maclaurin series sum expansion of the Q function. So our formula, series sum of the x values. That's x values raised all over square root of 2. Square root of 2. Raised to the power 2n plus 1, where 2n plus 1 starts from, that's 2 times 0 plus 1, that's 1. So it starts from 1, followed by 2 times 1 plus 1, 3. Next is 2 times 2 plus 1, 5. So 1, 3, 5, 7, 9, 11. That's the increment is 2. And the coefficient is 3. Is 8. This range. Now enter. And we continue. This is divided by square root of pi. So divide by square root of pi. Square root of pi. And finally, you add 0.5. So 0.5 plus the series sum. And we'll chart this. Insert scatter chart. Change this to scatter chart. And use row 1 as header. The series, we show the trend line. Polynomial to the 8th degree. And the label, use the equation. The legend, position it at the bottom. And here we have the trend line and trend line polynomial of the Q function. This is the trend line with the trend line polynomial to the 8th degree. Next, we enter the NORMSDIST. So this is equal to our formula, NORMSDIST of the x values. And the other one is GAUSS. So our formula, GAUSS of the x values. And we'll show the equation. Modify this to show the equation. Edit chart. The trend line polynomial. So trend line polynomial to the 8th degree. Label, use the equation. And the legend, position it at the bottom, which is bottom already. In the case of the series, the Gauss function changes to green to match the dataset. Now we'll calculate the polynomial regression coefficients for these trendline polynomials. To do that, we complete the LINEST matrix. So this is power transpose. To get the power transpose 0 to 8. And the elements. So are a formula of the x values raised to the power 0 to 8. Now we can enter LINEST, starting with the Q function. So LINEST data y and data x, followed by the NORMSDIST function. LINEST data y and data x, followed by the GAUSS function. LINEST data y and data x. Now we have the polynomial regression coefficients, and we'll match this. Next, we modify the NORMSDIST. We factor in the negative sign. So the blue dataset and the red dataset are the same, meaning the NORMSDIST will have the same dataset as the Q function. So the Q function now is the same as the NORMSDIST. And the trendline polynomials coefficient are also the same. Continue with the Gauss function. There's a negative sign here, so there's a negative sign on the x, so that's negative x, and add 0.5, so 0.5 plus Gauss function, 0.5 plus the Gauss function. Now the data sets are all the same. The polynomials are also the same. They're all in the trend lines are all the same, and the regression coefficients are the same. Starting with x to the 0, that's 0.5. X is minus 0.399. X squared, 0. This is 1.98 times 10 to the minus 19, that's already 0. 4.01 times 10 to the minus 23, this is already 0. X cubed, 0.0656, 0.0656. X to the fourth, that's negative 1.08 times 10 to the minus 18, that's already 0. 2.08 times 10 to the minus 22, that's already 0. X to the fifth, that's 8.79 times 10 to the minus 3, that's 8.79 times 10 to the minus 3. X to the sixth, this is 1.23 times 10 to the minus 18, that's very small, that's already 0. 2.2 times 10 to the minus 22, this is already 0. 5, the x to the seventh, 5.98 times 10 to the minus 4, 5.98 times 10 to the minus 4. X to the 8, negative 3.52 times 10 to the minus 19, negative 3.17 times 10 to the minus 23. These values are small, so this is 0. This completes the use of NORMSDIST, Gauss function, Taylor Maclaurin Series sum, and LINEST Polynomial Regression to generate the Q functions, trendline, and trendline polynomials.